Hello everyone, I am Sunil. I am studying BTech final year in Annamacharya Institute of Technology and Sciences, Rajampet in Triple branch. We have done a project on efficient power system operation for power loss reduction and voltage profile improvement by optimal placement of DSTATCOM using fuzzy and PS4 algorithm. We have done this project under the guidance of Mr. M. Ramesh and our batchmates are B. Nagasaroja, D. Sai Harshavardhan, T. Shivakarthik. Coming to the overview of presentation, it includes objective, introduction, existing system and modeling of DSTATCOM, problem formulation, optimal placement of DSTATCOM using fuzzy approach, proposed system, flowchart of PS4 and executive steps, results, conclusion, future scope and references. Objective. The objective of this presentation is to reduce the power loss and to improve the voltage profile in the radial distribution system. Fuzzy and particle swarm optimization algorithm is a two-stage methodology used for placement and sizing of DSTATCOM in this project. Introduction. Electrical transmission and distribution networks are complex. The generated power is reduced due to various losses present in the system. The end user power quality becomes poor due to degradation of the voltage profile. If the losses are reduced as minimum as possible, therefore the need and cost of additional energy generation are reduced. Existing system. ALSA algorithm. The lightning search algorithm is a novel meta-heuristic optimization method proposed in 2015 to solve the constraint optimization problems. The LSA is based on the natural phenomenon of lightning. The proposed optimization algorithm is generalized from the mechanism of step leader propagation. It considers the involvement of fast particles known as projectiles in the formation of binary tree structure of the step leader. It is based on the natural phenomenon of lightning and the mechanism of step leader propagation using the concept of fast particles known as projectiles. Three projectile types are developed to represent the transition projectiles that create the first step leader population, the space projectiles that attempt to become the leader, and the lead projectile that represent the projectile fired from the best position step leader. Disadvantages of existing system. Limited research and applications, parameter sensitivity, convergence speed, lack of diversity, scalability, premature convergence. The obtained results of the proposed system compared to the results of the existing system show that the losses of power presented in the proposed system is very less. PSO has been compared with other optimization algorithms and this survey shows that the PSO can produce better results than the other optimization techniques. Optimal placement of DSTATCOM using fuzzy approach. Main objectives to be considered while designing a fuzzy logic to identify the optimal placement of DSTATCOM are minimization of the power loss, maintaining voltage within the permissible limits. A fuzzy interface system consists a set of rules is then used to determine the DSTATCOM placement suitability of each node in the distribution system. In the first step, load flow solution for the original system is required to obtain the real and reactive power losses. Again, load flow solutions are required to obtain the power loss reduction by compensating the total reactive loads at every node of distribution system. The loss reductions are then linearly normalized into 0 to 1 range, with the highest loss reduction having a value of 1 and lowest value is 0. Power loss index value of nth node can be found by using the below equation. PL of n is equals to LR of n minus LR of minimum by LR of maximum minus LR of minimum. The input variables are power loss index and per unit nodal voltages. The output variable is DSTATCOM suitability index. Power loss index range varies from 0 to 1 and per unit nodal voltage range varies from 0.9 to 1.1. The output variable DSTATCOM SI range varies from 0 to 1. Rules for fuzzy. The rules are in the following format. If the power loss index is high and voltage is low, then DGSI is high. If power loss index is medium and voltage is N, then DGSI is low medium. If power loss index is high and voltage is high, then DGSI is low medium. Here if part of a rule is called rule antecedent and then part of the rule is called rule consequent. For 2 inputs and 5 membership functions, we have derived 25 rules. Proposed system particle swarm optimization. Particle swarm optimization is proposed by James Kennedy and Russell C. Ebert in 1995, which was inspired by fish schooling and bud flocks. It is a computational method that optimizes a problem by trying iteratively to improve the particular solution. Population of birds or fish is called as swarm. This is the flowchart of PSO algorithm. It starts with the initializing a population of particles with random velocity and positions, and then it evaluates the fitness value for each of the particles. If the current fitness value is greater than the previous p-best, then the value is replaced with the current one. Otherwise, keep the p-best value. Assign the p-best value of the best particle to the g-best. Update the velocity and position of the each particle. If the criterion is fulfilled, then the process stops. Otherwise, it goes to the another iteration. PSO execution steps. Let us examine the PSO execution steps. Initialize algorithm constants. Initialize the solution from the solution space. Evaluate the fitness of each particle. Update the individual and global pre-best. Update the velocity and position of each particle. Go to step 3 and repeat until the termination condition. The above flowchart detailing and organizing the execution steps. And these are the results of our project. For 33 bus system, the loss reduction curves are drawn at various intervals such as normal loading conditions, 125% of load, 150% of load and 175% of load. The below tabular column shows the values of real and reactive power losses before the placement of DSTATCOM and after the placement of DSTATCOM. And this is the result for 16 bus system. The graph shows the loss reduction curves of real and reactive power at different loads. The below tabular column shows the results for 16 bus system at different loading conditions. It consists of real and reactive power losses before the placement of DSTATCOM and after the placement of DSTATCOM. Conclusion. The combination of fuzzy and PSO has been used as a two-stage methodology in this project to reduce the power loss and to improve the voltage profile in radial distribution system. Various optimal locations are obtained by the DSTATCOM suitability index from fuzzy. Optimal sizes for the respective locations are obtained by using PSO. The result analysis also shows that the power loss of various loading levels is reduced and the voltage profile is maintained within the limits. Future scope. For the other power system optimization issues, the particle swarm optimization approach can be utilized. It may also be utilized to combine different fact devices, solve the problem of economic load dispatch, and use DSTATCOM and DG placement in the distribution networks. The placement of DSTATCOM in an unbalanced load scenario may be solved using this approach. And these are the references. Thank you.